Hello grade 12s. Right, today we're going to be looking at the standard normal distribution, and this we use when we need to compare any two distributions that don't have the same mean, don't have the same standard deviation, and we reduce both of them to the standard normal so that we are comparing apples with apples. Okay. The variable in a standard normal deviation is always z, okay, and it has a mean of 0 and a standard deviation of 1. Alright, a formula that you're going to be using a lot is that z equals x minus mu over sigma. You need to know that formula. And we can say that z is approximated by a normal distribution in 0 and 1. And what this formula tells us is that our value for x is however many standard deviations away from the mean. Okay. Now, not all data values are going to allow 1, 2, or 3 standard deviations from the mean. So once you've got your z value, we're going to use a new function in our calculator. And for that, we're going to use the cumulative normal distribution function. So before we worked with binomial distributions, now we're working with normal distributions. So let's have a look at how we're going to do that. The question says, calculate the values of the following probabilities. Probability of z being less than 2.5, or the probability of z being between negative 1.25 and positive 1.25. As soon as you see a z, it tells you it is a standard normal distribution, and we don't have to tell you what the mean and the standard deviation are because we know that they're 0 and 1. So z can be approximated by a normal distribution in z in 0 and 1. So our probability of z being less than 2.5, we're going to say using NCD on the graphics calculator. And let's have a look what that NCD looks like. Okay, so we're going to go to the statistics screen. We're going to go to normal. We're going to go NCD. Right. Now, data variable, our lower value, because we're going from negative infinity all the way up to 2.5 or anything less than 2.5, we want to choose a really big negative number. And our calculator can work with a really big negative number. Negative 1 times 10 to the 99. Okay? Our upper value we're looking for is 2.5. Sigma is 1 and mu is 0. And we get a value of 0.99378. So our lower is going to be negative 1 times 10 to the power of 99. Our upper is 2.5. Our sigma was 1 and now mu is 0. So therefore it is said was 0.9938. Alright, so for the next one, probability of negative 1.25 less than or equal to z less than or equal to 1.25. Alright, again now we've got a lower and an upper. We don't have to worry about going to infinity. remember that less than or equal to and less than are the same thing, or treated the same when we're working with continuous random variables, because we can't find an exact value. So using NCD on the graphics calculator, and we'll put it in now, but we've got our lower value, it's going to be our negative 1.25. Our upper value will be 1.25. We're still sitting with standard normal distribution, which means we have a standard deviation of 1 and a mean of 0. And let's go back here. We now have negative 1.25 and positive 1.25. We still got sigma and mu as they were. And we have 0.7887. So our probability of Z being between negative 1.25 and 1.25 is 0.7887. Alright. Now X is normally distributed, and just now we're working with X's, such that X is approximated by a normal distribution in 25 and 3 squared. Remember that our normal distribution is characterized by mu and sigma squared, so that then tells us that our mean is 25 and our standard deviation is 3, not 3 squared. Be careful. Okay. So our probability of X being greater than 27. Well, now we're working with the variable X. It's no longer the variable Z. So we're going to use a calculator using NCD on the graphics calculator. And our lower value, I'm just going to write them quickly, upper value, sigma and mu. Well, we know that our sigma is going to be 3 and our mu is 25. Our lower value, X is greater than 27, so our lower value is 27. And our upper value has to be a really big positive number. So let's go with 1 times 10 to the power of 99. Okay, so let's have a look at what our calculator does with that. And you just need to remember these really big negative and really big positive numbers. Oops. Distribution, normal, NCD. So our lower value is now 27. Our upper value is 1 times 10 to the power of 99. And no longer is our sigma 1, it's now 3. And our mean is 25. And when we push our equal sign, we get the probability is 0.2525. So our probability of X being greater than 27 is 0.2525. Alright, now we have to convert X to a standard normal variable. And to do that, we use our formula. That is, Z is X minus mu over sigma. And we use the X value that we're working with at the time. So 27 minus 25 over 3. And that's equal to 2/3. So that tells us that our corresponding X value is 2/3 of a standard deviation away from the mean.